All right, it's another session, although today is not a Saturday, it's a holiday in Ghana, so we decided to take advantage of it and then have one of our sessions today. Because we'll be looking at storage and databases. So like I always do, I introduce myself. By now, everyone here knows me, so we shouldn't spend much time on this slide. So today we intend to look at block storage and then file storage, and then we look at object storage. We look at transfer services. We also look at relational databases and then non-relational databases. Non-relational databases are also known as NoSQL databases. So that's our agenda for today. Before we start, any questions from last week? Last week we spent a lot of time here. We exceeded our time because there was a lot to do. So if you have any questions from last week, this is the time you can ask, and then I'll address them, and then we move on. I don't see any hands, so I guess I can proceed. Okay. So let's look at block storage. There's a service on AWS called the Elastic Block Store or block storage. So it's shortened as EBS. And anytime you create an EC2 instance, you're likely to also create an EBS volume. So what EBS is what they refer to as block storage. So this is a generic IT hardware, right? In a typical IT environment, you have what they call a block storage or storage area network. So you have like some storage equipment that the VMs would store their data and applications on. It's not directly attached to the VM. It's external to the VM and it's accessed over a network. So it's the same concept, it's the same thing. However, this time it's in the cloud and it's managed by AWS for you. So all you do is when you're launching your instances, you can request for a block storage and then it's attached to your instance. The important thing to note here is that it's not physically on the host where your instance is. If I say host, I mean the server that your instance has been created on. Block storage is not on that. It's on an external system. You access it over a network. And because they are usually in a local network, access to it is very fast. You'll not even realize any latencies because it's external to the host of the instance. ECS is very flexible, so you can decide on the storage size, you can decide on the type, we'll look at type. You can decide on IOPS. IOPS is input-output operations per second. So we'll look at what that is also. EBS volumes, like I said, are external to the host of the instance, and so they store data independently of the instance lifecycle. So you can terminate an instance and still keep the EBS volume. You can later use that volume on another instance or create a snapshot from it. So, of course, I think the default configuration is that when you terminate an EBS, an EC2 instance, the volume attached to it is also terminated, but you can change that setting so that when you terminate an instance, the volume is still there. So you can use ABS volume as your system drive. You can use it as your boot volume. So that's where your operating system is loaded from. You can use it as storage for your web applications or even databases. And EBS volumes can be attached to a single instance. Also, there are some volumes, especially the IOPS or provisioned IOPS volumes, you can attach them to multiple instances at a time. It's not all volumes that support that. I think the provisioned IOPS volumes are the only ones that support multi-attach. So I spoke about types of EBS volumes. There are 4 types of EBS volumes. Some of the types, there were some other types too, but those are old generation types and they are no longer in use. So these are the 4 types that you can use. So you have the general purpose, as the name goes. If you just want a volume, you don't have any special use cases, or you even don't know what you want, you can just go with the general purpose, and you can say I have GP2 and GP3 by the general purpose. So these are different versions of the general purpose. GP3 is the current generation for general purpose. It succeeded the GP2. You can create any of them. However, GP3 is generally cost-effective and highly performant than GP2. So a higher generation is always like better, gives you a better performance and costs than the previous generation. So general purpose volumes usually would give you a balance of price and performance. There are some volumes that will give you a very good price, but the performance is low. Some to give you very high performance, and then that will go with very high price. That's provisioned IOPS. But the general purpose tries to balance it. You have your performance, not the most performant volume, but also the price is good. So there's a balance. You usually use it for your boot volumes and then small mid-sized databases. And I'll say over here that provisioned IOPS are, general purpose and provisioned IOPS, they use SSD, and then the lower, the third and fourth, that's throughput optimized, and cold HDD use hard disk. So hard disks have magnetic tapes in them, and you have some moving parts and all that. But SSD means solid state drive. It's like a circuit that stores data. There are no moving parts like you find in the HDD. So provisioned IOPS and general purpose, they use SSD. They are fast. And so now I'm on provisioned IOPS. You have IO1 and IO2. There are different variants, but I think for the purpose of the associate exams, just knowing the provisioned IOPS is okay. And that's for mission critical or low latency or high throughput workloads. So what they allow you to do is that you can do a lot of input and output operations per second. So if you run an application that does a lot of inputs and outputs, and you need more than 16,000 inputs and outputs operations per second, then provisioned IOPS is the way to go. Other than that, you can go for general purpose. General purpose will give you IOPS also, but it will not exceed the 16,000. And in previous generations, the IOPS was mapped to the storage volume you were requesting for. So the size of the storage. By GP3, you can go. You can specify IOPS. You can specify IOPS separately from the volume size. So the lower or the third and fourth types, those are hard disks. You have ST1 and SC1. So throughput optimized, you'd use it for workloads that require high throughput. So throughput is like a lot of data, right? You are storing a lot of data. IOPS is input and output operations. So you're either reading data a lot or changing data frequently. So that's when IOPS come. But throughput is basically for storage. So you have like huge files you want to store. That's where you use the throughput optimized. You can use the general purpose for that also, but throughput optimized is used for such workloads. So if you have a big data or a data warehouse, you want to store data, you can use this. Later, we'll see other options for data warehouse or big data. You can also use it for log processing. You may need to access this data for processing. So you would want to store it on throughput optimized. However, if you have such data and you will not be accessing it frequently, then you could use the code HDD. So code HDD is for, or code hard disk SC1 is for data that you don't access frequently. And then that one has the lowest price. Has the lowest price. But you only use it for data that you don't access frequently. So usually use it for logs, archiving logs, right? Logs that you're already done processing, but you need to keep it for a long time. You can use code HDD for that. EBS snapshots. Remember 2 weeks ago, we created AMIs, right? We created the AMIs from our EC2 instance. So snapshots are just like AMIs. Joey, go ahead.
Good morning.
Good morning, Joey.
Yeah, please. I'd like to a bit of difference. The provision IO2 and provision IO1 and Nitro. What's the difference between these three? And in terms of HPC, that is high performance computing, is it advisable to use either IO2 or IO1? Or does it depend on the EC2 type?
Okay. So I mentioned somewhere in my presentation that a current generation of a volume type would usually give you a better performance and is cost effective than a previous generation, right? So if you want the best of performance, you use IO2. They all have performance ranges. I just didn't add them. You can refer to them later, but generally IO2 would give you a better performance and then a better pricing, like maybe the same workload or the same performance from a previous generation. IO2 will do that for you at a lower price. That's not always the case, but usually a newer generation will give you, it's more cost effective than the previous generation. In terms of HPC, like you said, it depends on what you are doing. So if what you are doing requires low latency, or you have a lot of data changing on the storage, then IOPS is what you want to do. You want to use. If the HPC is doing more of some calculations that does not depend on the storage, then you don't need the provisioned IOPS. And Nitro is a virtualization platform, right? So it's not just storage; it would virtualize your instance, storage, networking, and other security features. So it doesn't really apply to storage. And it's AWS's own virtualization platform. So most of the new instances, all the new instances will be based on Nitro. Did I answer your question? I left some out.
Yes, it does. But the only thing I want to really understand, assuming you want to do the HPC based on calculation of, I think, biological programming or stuff, they usually, I've seen somewhere where they say you can use an EC2 type. There are certain EC2 types that you can use.
Yes.
So I wanted to understand.
Okay.
Can you use IOPS, provisioned EBS in place of those EC2 types, or you can't, or it's just specifically for EC2 instances only?
Okay. So you don't use EBS on its own, right? It needs to be attached to an instance. Like it's a storage, but how do you get data in there? It has to be attached to an instance before you can get the storage. Do you get that point?
Yes, I do now.
Okay. So when you have an HPC, there are actually two types of block storage. For HPCs, you can have an EC2 instance type that does HPC, high performance computing, right? And EC2 instances usually have two kinds of storage. We'll look at the other type very soon. The other type is called the instance store. So that storage is actually on the host it's on the host machine. So remember I said EBS is actually accessed over a network interface. It's not directly attached to the host or the physical server we have the instance on. However, instance store is actually on the host system. And so you'd usually use that when you want very fast, low latency access to your data. However, the reason why we don't use instance store mostly is because it's not as it's ephemeral. So when you say something is ephemeral, it means that when the host machine becomes faulty, you may lose access to your data. Or when you turn it off or terminate it, you lose access to the data. So it behaves like a RAM. It's not a RAM, but I mean, with the features I've given it, that's how a RAM also behaves, right? So you not usually use that. However, if you need very low latency and you can get your data from elsewhere, you can load it into the instance store, and then HPC can use the instance store. If the data is on an EBS volume and you are doing a lot of reads and writes and updates, then you can use the latest version of provisioned IOPS. So I believe that will address your issues.
Yes, thank you so much.
You're welcome. So snapshots basically is backing up your EBS volume, right? You back it up into S3. One cool thing about EBS snapshots is that it's incremental. So incremental means that anytime you back it up, it won't perform a full backup. You only back up the changes that have occurred. So a change could be new data or an update to an existing data. So maybe the first time you are backing up or taking a snapshot of your volume, it would take the full backup because it's the first time. However, let's say today we take our first snapshot. It takes a full backup. And then maybe in the afternoon, we download a movie, which is 10 gig, or an application, which is maybe 2 gig, right? If we take the snapshot again tomorrow, the latest snapshots would only have the 2 gig application we downloaded, and it will reference the snapshot we took today. And subsequent snapshots will behave like that. We can create volumes from snapshots. So like the way we created instances from snapshots, from AMIs, we could create volumes from snapshots. When you delete a snapshot, it only deletes the specifics. It only deletes the data unique to that specific snapshot. Remember, I said that snapshots reference previous snapshots, right? So if maybe we have 5 snapshots for a specific volume, and or we've taken 5 snapshots so far for a specific volume, and we decide to delete snapshot number 4, it would only delete the data related to snapshot number 4, or the changes that were reflected in snapshot number 4. All the other snapshots will be kept there. If we have an EC2 instance with an EBS volume attached, and we decide to encrypt the EBS volume. In lesson 1, we're supposed to look at encryption at rest. That's through KMS. That service basically gives us encryption keys to encrypt our data on different AWS services. So if we decide to encrypt our volume and we take a snapshot of that volume, the snapshot will be encrypted, meaning that we need the key that was used to encrypt to be able to decrypt it. If you have a snapshot that is unencrypted and you want to encrypt it, you have to take note of this statement I'm going to make. It's actually a possible exam question, like that can be asked. I don't know if I'm allowed to say that, but I mean, it's something that is very examinable. So if I have a snapshot that is unencrypted, right, and I want to encrypt it, you cannot just go and encrypt it like that. You have to create a volume and then encrypt the volume and take a snapshot of the encrypted volume. Is that understood? I'll repeat it again. If you have an unencrypted snapshot and you want to encrypt it, we all know what encryption is, right? We didn't learn encryption here, but I believe we all know encryption. Encryption is using some cryptographic material, right, to make sure that your data is not readable, or when somebody sees your data, it's not readable. It's changed using some mathematical operations, right? Your data is changed altogether. So when somebody sees the data, they can't read it by just looking at the data. They will need the cryptographic material. There are different ways of doing it anyway. Yes, so they will need some cryptographic material, which is referred to as a key, to be able to unencrypt it or decrypt it. So that's what the encryption is. And remember that with the cloud, we are saving our data elsewhere. So we want to make sure that just in case somebody chances on our data, they are not able to read it or access it, unless we've given them permissions to our keys. You remember we learned about IAM, where we give permissions for everything. So even to decrypt data, you need permissions to do that. So yes, in the cloud, you want to encrypt all your data. All the services we've looked at, when you are using them, of course, some of them encryption at rest doesn't apply. But where it applies, where you need to store data on a volume or somewhere, you would have to use encryption. which is KMS. KMS is the service, key management service. We use it to encrypt at rest. Since I'm talking about encryption, and I may not talk about encryption again, and this is a boot camp, let me just chip it in here that there's also another form of encryption, which is called encryption in transit. And encryption in transit is actually independent of AWS. It's an open protocol where that's HTTPS, right? Secured HTTP. So when you're transferring data from one place to another, you have to make sure that it is encrypted, or you use HTTPS to transfer that data, so that nobody, when somebody even snoops and sees the data, they'll not be able to decrypt it. So that's encryption in transit. There are two: encryption at rest and encryption in transit. Encryption in transit is on storage, and then encryption at rest is usually on the storage or when data is stored somewhere, right? And then encryption in transit is when you are moving data. So for instance, when you go and open a site, data is moving from the server to you. So definitely your data transits or moves from one place to the other. And that's where you use the encryption in transit, HTTPS. All right. So I spoke about incremental snapshots. I thought I should give you some visualization here so that you understand it better. So let's look at stage 1, which is the first snapshot. When you take the first snapshot, you realize that the snapshot volume is 10 gig. The volume itself is 10 gig. So when you take the first snapshot, that's 10 gig. You take the full volume snapshots the first time. Now, at stage 2, maybe that's tomorrow. So today we were working on our volume or our instance, which would write or update our volume. And we so happen to change 4 gig of data. Mind you, we didn't add any data, we changed. Out of the 10 gig, we changed. So it could mean that we had some file where we had some updates to that file, and maybe the file was 4 gig, and then we make some updates, and so the file is 4 gig, but the data in it, the file itself has changed, right? So we have 4 gig data change. What will happen is that when we take our second snapshot, the second snapshot is only going to have 4 gig of data, and the reference the 6 gig of data that did not change. Another time, we take another snapshot, and then the change that we have is that we added additional 2 gig to the data. So now the data is 12 gig. Our third snapshot will just have the 2 gig we added and the reference the 2 snapshots we had. So you realize that we only keep adding to the snapshot the changes that were made or new additions. We don't copy the whole thing again after the first snapshot. So that's incremental snapshots. So what we look at for snapshots here, they apply to databases also. We'll look at databases later, especially the RDS service. When you take snapshots, it just takes the full database instance snapshots, and then you can incrementally add snapshots to them. So let's note this. However, what we just discussed here are for volumes. Mind you, the database uses instances, and they have EBS volumes attached also. So it's the same principle over there. If you understand this, you apply it there also. I spoke about instance store earlier, so I won't waste much time on it. Like I said, it can be found directly on the host system, and it's for very fast or low latency data access. So when you want to create a buffer or a cache, then you can use it. And like I said, it's a temporary storage. So if you want to keep data for a very long time, that's not where you keep it. You usually keep data that you can get from elsewhere, or you copy it to another place, which is persistent. That's when you can use this instance store for all the benefits it gives. Now, when you stop the instance, or you hibernate it, or you terminate it, your data is lost. So you have to note that. Now we are done with EBS. We're moving on to another storage system. So the first storage was block store. Now, one thing I didn't do was explain why we call it a block storage. So block storage, I think we are all used to how files are stored, right? So on your computer, when you store a file, you have an idea that the file is stored. Maybe if the file is 1 gig, you have an idea that the file is stored 1 gig at some place in the hard disk, right? However, for block storage, it's not like that. Your file is actually divided into different blocks and stored at different places on the block store. When you want to access the file, they are assembled together and then given back to you. So that's how block storage works. I think yes, it's good I explained it like that. Now, file system behaves like the file system we know, elastic file system. It's different from the block store. However, it also works differently from the block store. One thing I didn't mention about the EBS is that EBS only works in a single availability zone. You remember when we created instances, we said that you would spread your instances across multiple availability zones for high availability, so that when one availability zone fails, you would be able to get your workload running because other availability zones will be online and you have instances in them. So you are not impacted much when a single availability or even two availability zones fail. However, AWS volumes are created in an availability zone. They are stored redundantly in that availability zone. So when you create an AWS volume, the data on it is actually backed up by AWS automatically in that availability zone. Just in case the AWS volume fails, AWS can always recreate it for you because they have a backup of it. So even before you create your snapshots, they have a backup for you. Why did I come up with all this? It's because of how EFS or Elastic File System gives. So Elastic File System would actually allow you to create a storage that is accessible across multiple availability zones in a region. Actually, your EFS system, you can even access it from your on-premise data center if you have direct connect or a VPN. Kofi Ade, please go ahead and ask your question.
Yeah, hi everyone. Yeah, I just got a question in regards to the EBS. You mentioned that you can set it up at one specific availability zone. What about in a case whereby you want to transfer it to a different AZ or probably a different region? Is that possible?
It's possible actually. You remember we talked about snapshots, right?
Yeah.
Yeah, so you use snapshots. Snapshots as a copy of your EBS volume. So you can actually move the snapshots into a different region. Or in a different availability zone, you can create a volume, an EBS volume from that snapshot and use it in a different availability zone. So that's why snapshots were not only for backups, they're actually for disaster recovery and then replicating the same data across multiple availability zones. Does that answer your question?
Yeah, it does. So in terms of that, do you need to encrypt it before you make the transfer of that EBS
No.
to different regions? You don't have
So
to.
you can actually keep it unencrypted or create snapshots that are not encrypted, right? Like I explained earlier. But it's not the most secure thing to do. You would not want to do that. You don't know who has access. This is somebody's computer, even though we trust AWS and their staff that they are professional and they will not go and view our data. It is not advisable to leave it unencrypted. In an exam, if you go and select an option that is unencrypted, you get it wrong. Like, you always have to make sure you encrypt your data. Also, in the real life, you want, we have what we call assurance, right? You want to be able to go and sleep at night without thinking that somebody may actually be able to read your data. So you would want to encrypt your volumes and your snapshots. And since we are talking about encryption again, let me mention it again. I can't overemphasize it enough. If you want an encrypted snapshot, the volume must be encrypted. If you have an unencrypted volume and you create a snapshot, the snapshot will be unencrypted. However, if you have an unencrypted snapshot and you want to encrypt it, now you have to create a volume from that snapshot. As creating the volume, you encrypt the volume, and now you can create an encrypted snapshot from the volume, because the volume you created, the volume the snapshot is from is already encrypted. So yes, that answers your question, right? So now,
Yeah,
good. 2FS. EFS is one of the coolest file systems there is, right? Because you can actually use it across multiple availability zones. You can let your on-premise data center access your EFS file system in the cloud. You can actually use an EFS file system across regions. Yes, we learned about networking last week, so you can use those the things we learned there to access your EFS files in other regions. That's not the only cool thing about EFS. You see, I'm waxing lyrical about EFS, right? You remember I said EBS is flexible, where you could specify the volume size, let's say 10 gig or 1 terabyte, right? EFS, you actually don't specify a volume size. The file system grows as your files grow. So like you don't even think about the size of the storage. You just keep adding files to it, and it would scale automatically to so I'm trying to meet somebody. Who else is unmuted? Okay. So let's go. Yeah, so your file system will grow as your files are growing. You can use it with EC2, ECS, that's the Elastic Container Service. There's EKS, Elastic Kubernetes Service. You could even use it with your Lambda functions. So where you have big data applications, or you want to do some analytics, and you have instances spread across multiple availability zones, you would use EFS to keep the file so that each instance can access the data at the same time. Remember I said that EBS can be attached to one instance at a time, even though some volume types allow you to attach it to multiple instances. EFS comes natively with that feature where you mount the file system as one of your devices on your instance. So it makes it very easy when you want to share data among a group of instances. So the same applies for media processing and content management, and even serving websites. Remember the last time we created the auto-scaling groups, each of them had their own EBS volumes. Yeah, could figure ahead.
Yeah, just a quick one. With the EFS, does it work with all operating systems?
It only works with Linux. So I have it on the first point that it only works with Linux.
Okay, what about Windows then?
I'll address it very shortly.
Okay, thanks.
Okay. So our favorite friend, security groups, are used to allow network access to the EFS file system. So there are certain ports you have to allow for the EFS file system. You use IAM permissions for allowing access to the resource itself. So who can create a file system or access the file system. So EFS would work on, or it supports NFS, that's Network File System version 4, and then version 4.1. So wherever you see NFS, then it means that EFS could work natively. Like if you have a file system, or if you want to use an NFS file system, then it means that you could use EFS. Okay. So we look at the concept of storage classes. Data, AWS will tell you that they're a customer obsessed company, right? So they do things that their customers want. So after running or managing services like EFS, they realize that there are different access patterns, right? How people use the data and all that. So they came up with storage classes. So the standard EFS standard is there. This actually applies to S3 also, which is an object storage. And then also DynamoDB also has something similar. So your storage classes would basically tell you how your data is stored, whether it's stored across multiple availability zones, and then also how quickly you access the data. So if it's stored at maybe just one availability zone, it makes the price lower. If it is stored as an infrequently accessed storage class, it means that you will not access the data a lot. So that one, they can give you a lower price and store it in such a way that it is not frequently accessed. However, if you want to access it, then maybe your price goes up a bit. So the standard will store your data. EFS standard stores your data across multiple availability zones. Is the default I mentioned, and if you don't specify any storage class, that's what you would use, right? So it's ideal for workloads that you require the high levels of availability and durability, right? Durability means that your data is accurate, is stored as you want it, all versions of your data are the same and all that. Standard infrequent is similar to the standard. However, with standard infrequent, you are not going to access it every day, right? You may access it maybe just once a month. So you may access your data just once a month. So you can save on the EFS standard. Your data will still be stored across multiple availability zones. However, it is stored such that you do not access it frequently. One zone would also give you a lot of cost savings because your EFS file system would only be created in one availability zone. One zone IA is similar to one zone. However, one zone IA has the additional feature where, or in one zone IA, is still stored in one availability zone, but you access it infrequently. So that would be like the cheapest storage class. If you don't want to worry yourself with moving data across these various storage classes. What you could do is use the intelligent steering, where it uses a feature called Lifecycle Manager to look at how you're accessing your files. And then you also set some rules. And then based on that, you can move your data across the EFS standard IA or one zone, depending on what you want to do. So if you want performance, then you would use EFS, or you want to access it frequently, you would use EFS standard and then one zone. I mean, you move it from EFS standard to EFS one zone. If you want a lower cost for data that is not frequently accessed, and then you move it from standard to standard IA, or one zone to one zone IA. So yeah, intelligent steering would automatically handle that for you. Our weekly Zoom reconnection just occurred. So I hope we are all back. Are we back? Can you hear me? Am I talking?
We can hear you.
But my screen, but my screen is not shared. Eh?
No.
Okay.
Hello?
Yeah, I can hear you. Let me go back and share my screen. Okay, so someone asked, how about Windows? FXX is just like everything I've said about EFS, right? Think about it like that. It's just like EFS. However, it supports both Windows and Linux. So if you have Windows workloads, then your only option is FXX. And then if you have Linux, you could use either FXX or EFS. However, most Linux people will prefer the EFS. Okay, so FSX supports 4 file systems, right? ONTAP, OpenZFS, Windows File Server, and Lastra. You realize there's no NFS here. So if the question is scalable file system for NFS, or that supports NFS, then it's EFS. However, these other 4 file systems are supported by FSX. I mentioned that you use security groups to give network access to your instances to access the FSX file systems. The file system doesn't come automatically mounted with the instance. So remember, we use user data in session 2 to install Nginx. You could use the user data to install necessary packages for the file system, which is FSX. I mean, any of the 4 file systems. Then you can also configure it such that when your instance restarts, the file system is automatically mounted. So use user data for that. All right. So I think it's 11. We can take our usual 10 minutes break. And then when we come back, we'll do a slide. We just look at what we can do with EFS, EBS, something small, and then we'll move on to object storage. So 10 minutes. believe we are all back. Okay. Looks like we are here, so we can proceed. So, Kenwood, you're asking about the slides from last week, right? Kenwood, are you here?
Yes, I'm here.
Yes. So it's in the channel. It's in the Slack channel.
Okay,
I
okay.
posted it last week.
Okay, thank you.
Are you guys 3 people or it's just you? I see MGJO and Kenwood. Is it 3 people or it's just you?
I think it's me for now.
Okay. All right. Let's just do something small with this EDS. Nothing much. I'm just explaining or trying to rehash some of the concepts I spoke about earlier. So let's start by creating an instance. All right. Bootcamp instance. And then we could use our Amazon line S4. That's okay. Instance type. You can select a keeper. Our network is okay. So realize that I have a root volume, right? When it comes to storage, I have a root volume. And this volume is where my OS is loaded from, or my AMI would even be installed or copied to. I could actually add other volumes. So let's say add new volume. So you realize that what it gave me was GP2 initially. I could change it to any of the types we've spoken about. So we have GP2, GP3. We have code HDD. Magnetic is quite old. I don't know why it's still here. So all the types I spoke about are here. Okay. If I could add another volume, I could change this volume to 100 gig or even 1 terabyte. That's what we have here. So GP3. Let's say I also want to use IO2. What happens? Okay, I could actually create it. And I could go on and add other volumes. So when I go to advanced, realize that because I chose the IO2, now it's giving me an IOPS of 64,000. I could change this to what, 4,000? I could also come here and then realize that my IOPS for GP2 is 100 over 3,000. The maximum I can do is 3,000. Let me change my size to 1,000, which is 1 terabyte, and see what happens. Realize my IOPS gets to 3,000, and it's the maximum. If I add nothing else, so let's say 4 TB, it takes me to 12,000. Okay, so that's 4 times the 3,000. Okay, so let's just do 8, which is 24,000, and see what happens. So remember I said that you select the provisioned IOPS when you want IOPS more than 16,000. Because realize that from 1 TB, I get an IOPS of 3,000, and there's some mathematics to this. So you can go and look at the maths. I just want to bring to your attention that the general purpose has a limit on the IOPS. Now let's change this to GP3 and see what happens. So GP3, realize that now I can update my IOPS. So let me update this to 24,000 and see what happens. Okay, so it must be between 3,000 and 16,000. However, I can change my IOPS to say 1,000. Sorry, because this is 8 terabytes, it should be at least 3,000. So let me make it 4,000. That works. However, if I was using GP2, AWS would have calculated the IOPS for me. So one difference between GP2 and GP3 is that you can specify your IOPS. GP3, you can specify your IOPS. You can't cross 16,000, but you can specify the IOPS. If it's at least 1 terabyte or more, then your minimum IOPS should be 3,000. And if it is less, you can select lower. So the main difference between, one of the differences between GP2 and GP3 is GP3, you can give your own IOPS. That's not possible with GP2. So GP3 behaves a bit like the IO or provisioned IOPS, just that provisioned IOPS can go higher. So I was giving what I could do 64,000, right? I think I can even do 100,000. Now what's I think the highest IOPS is like 128,000. Okay, still 64 terabytes. Where's my volume? It's gone. Okay. So let's select IO2 again, and then let's select 65,000 just to prove that 64,000. Okay, good. So 64,000. Some volumes can go above this. So let's try 40,000 TB. This 16 TB, okay. All right. So just to play with the IOPS and the types we're talking about, right? Okay, so let me just add one volume, which is 8 terabytes with 4,000. Let me just make it 1 terabyte. I don't need that much. And I'll delete it right after. So one of the things I wanted to show here is actually delete on termination. Let me click on this and then we'll see why it's important. I spoke about it earlier. I just want to make sure it sticks. So this indicates whether a volume should be automatically deleted when the instance is terminated. If you disable this feature, the volume will persist independently from the running life of the instance. So if I don't want my volume to be terminated when the EC2 instance is terminated, I have to select no here. If I wanted to go with this EC2, then I have to make it yes. Then this is the encryption we spoke about over and over and over. So if I select yes, now I have to select an encryption key. There's a default key. So this is called an AWS managed key, meaning that AWS creates and manages it's for you. You can actually create one on your own, and it's called a customer managed key. So we can select this encryption, and then now we can launch our instance. I know I've not done something right. That's true. So let me just set my encryption to 1,000. My IOPS to 1,000. I don't need that much. I'm not going to do anything with the instance, actually. Okay. If you have created an EBS, we won't do that in this demo. But if you created an EBS volume, you could actually go and change the size of the volume, even though you've created it already. You remember we said it's flexible, right? So you could actually go and change the size. When you change the size, you also have to log into the EC2 instance and then update the size or grow the storage to reflect the new size. So that's what is usually done. So our instance is now running. Let's look at storage. We have our EBS, and then the root device name is this. Is that when I check my mounted instances, I should see this, right? Okay. Now we have 2 volumes attached to this instance, both 1 TB. One is encrypted, the other is not. You remember the permissions I set, right? So one will delete on termination, the other will not delete on termination. And then the one we've encrypted, this is the key ID. So one of our volumes is encrypted, the other is not. Our root volumes are actually encrypted. So that's this one. Okay. Now in the console, if I want to see my volumes, all my volumes, this is where I come to. So you realize the lower 2 are the ones I created. I just created, right? And then this is for an instance I have already. Let me see. Let's go to our instances. Okay, so when we go to our instances, let me remove this filter. I realize I have another instance here. Let me terminate it. So we see that we see the default behavior. The EBS volume will also be terminated, right? So this is the EBS volume for that instance. It is currently what in use. Let's refresh it and see. It should be terminated very soon. Participants. Who else is unmuted? Okay, it's gone. All right. So let's refresh this again. It takes a while to terminate. Okay. So whilst that is happening, let's look at snapshots. There's an interesting relationship between snapshots and AMIs. You see a description here is created by create image. So anytime we created an AMI, it's actually created a snapshot. So these are all the AMIs we created. Let's look at the dates they were created. You see 30th here, and then you see 23rd. All these times we're doing demos here. So these were from. Now let's undo much with this, but you realize I can create a volume from the snapshot, and then I can create an image. That's an AMI. I can copy the snapshot to another region. Can modify the permissions on who can use the snapshots. And yeah, among other features. I think these are the most important features, right? Okay. So let's look at our volumes again. Our volume doesn't want to go. It takes a while anyway. So with that being said, I believe we can move on to object storage. Yeah, we get the idea. I just wanted to explain a few things over again so we don't forget what we've just been introduced to. Okay, so our volume has finally vanished, and we are left with the two we created for the other one. Okay, so now let's move on to object storage. One of the widely used AWS services. But before I go on, is there any question from EBS? If not, I quickly move to object storage. So one of the favorite or most widely used AWS services is the simple storage service, otherwise known as S3. It's one of the widely used services because of its features. So we looked at block storage, we looked at file storage, now looking at object storage. Why do they, in object storage, the things are a bit different than we know, right? So an object is actually a file, a key, and metadata. So let me explain. The file is the file. We know what the file is. So a file could be a Word document, a PDF document, a video, a song, a picture. That's a file. The key is the name of the file. And then the metadata is other data associated with the file. So data about the file. So metadata could be the size of the file, when the file was created, who created the file, all those things, right? So all these things come together to make up the objects. And in object storage, there are no folders. However, you could mimic your folder structure with what you call prefix. So when you see anything, when you see the word prefix in relation to object storage, it's actually like a folder, but it is not a folder. So I told you object storage is a bit different from file storage or the other types of storage we have come to know, right? So you use prefixes to denote folders. Yeah. And the nice thing about object storage is that just like the EFS, you don't need to define the size of the storage. It's unlimited. You can store as many files as possible. It's highly available. There's a lot of security built into it, and it's highly performant as well. So in object storage, you store your data as objects in a bucket. So a bucket is a container where you store. Container doesn't mean the compute container, Docker and those. No, containers, no. Something that stores a group of things, right? That's a container. That's container I'm referring to. Good. So a bucket is used to store objects. So it typically creates a bucket and then you add objects to it. So when you create a bucket and upload objects or put objects into it, I think by default they are private, and you have to give people access to access. You have to give people permissions to access the objects and even the bucket itself. And you can, there are lots of configurations you can do for S3, depending on what you want to do. So S3 is used for a lot of things. Most of us use Netflix and Amazon Prime and all that. The videos we've been watching, yeah, they are stored there. Some of the apps we use when we upload images and all that, they are stored in S3. You can use S3 for your backups. You remember I said snapshots are actually stored in S3. So all those, when you back up your EBS volume, it's actually stored in S3. In the next session, we'll look at the concept of disaster recovery as well as the well-architected framework. So we'll talk more about disaster recovery there. Data lakes. So companies that analyze lots of data, they store all forms of data in S3, and then they have different tools, some from AWS, some from other third parties, to analyze the data. If you want to archive data, there's a way to do that in S3. You can also use S3 to host a static website. If you want to use file sharing, right? Like Dropbox and the likes, you can use S3 to store those files and share with other people. So companies would usually have repositories for their code and then their build artifacts. You can use S3 to store that. The use cases are a lot. They are non-exhaustive. These are some of the things you can do with S3. I mentioned that there are different ways to configure S3 for access. So by default, when you create a bucket, you block public access, meaning that no one else, let's say on the internet, even the URL to the object, can access it. This is enabled for buckets and even at the account level, right? So now when you block public access, that's external. But within your account, you can use the IAM policies to grant people access. You could even use roles, cross account roles. I think in the first session on security, I gave permissions to another account and then I accessed the S3 bucket of another account, right? So you could use that to give access to other accounts on your S3 bucket. We spoke about resource-based policies in week 1. And so bucket policies are resource-based policies. They look like IAM policies, however, they are configured on a resource. So the resource here is the S3 bucket. What you do is you tell in the bucket policy, you mention the principals that should be able to access the bucket. They are evaluated together with IAM policies when they're trying to give access to S3 objects and even buckets. Access control lists, ACLs. So use it to grant read and write permissions to users. So ACLs were an old way of granting permissions. They are still allowed, but it's an old way. So the advice is not to use it. You could use IAM or bucket policies to grant access. There are some configurations also called the object ownership. So that's when it's enabled, it will automatically disable the ACLs. Remember, I said that ACLs are not encouraged to be used. And what it also does is that automatically grants ownership of every object in the bucket to the account, owner of the account, right? So it's a simple way to manage access. Why object ownership? Remember, we said that you can give access to another account or other users, right? So when they upload objects with ACLs, there's a configuration where the person who uploaded the objects becomes the owner. But with object ownership, you can actually say that irrespective of whoever uploaded the objects, the owner of the bucket is the owner of the objects. That makes sense, right? Okay. Now let's look at storage classes. Let's remember that we've seen storage classes at EFS, Elastic File System. It's similar here also. S3 has 4 storage classes. So the first one is the default, which is S3 standard. And S3 would store your objects in at least 3 availability zones. So store your objects in at least 3 availability zones. So standard, at least your data is replicated across 3 availability zones. If anything happens to one availability zone, you can always access your data from another availability zone. Mind you, you don't choose where you access your data from. It's all abstracted from you. It's just AWS way of making your data resilient and durable, right? When you choose reduce redundancy, now you are saying that you don't want your data to be at multiple availability zones, right? It should just be at, let's say, one availability zone, and then you can access it from there. You do that when the data or workload is non-critical, or you can easily reproduce the data. So you don't care about it being stored redundantly, right? Because you can easily reproduce the data. S3 standard infrequent access is similar to S3 standard. However, you are saying that even though your data is stored across multiple availability zones for durability and resilience, you would not be accessing the data frequently, right? So they should store it such that it's not available for frequent access. Then the one zone infrequent is similar to the reduced redundancy in the sense that it's stored at only one availability zone, and similar to the S3 standard infrequent access in that you access the data infrequently. So you pay little or you spend less in storing data. So why did we look at storage classes, right? Storage classes are used, you typically use multiple storage classes, or you create rules that will transition your objects through multiple storage classes, depending on the access level and or frequency of access, right? So S3 lifecycle is basically a configuration which will contain a set of rules that tells S3 what to do to your objects. What does that mean? In simple terms, you can tell S3 that maybe after 30 days, expire an object. When you expire an object, it means that it is removed from S3, it is deleted automatically after 30 days. So you don't have to pay for storage of that object, right? Because it's expired, you no longer need it. Also, you could say that S3 should transition the object. Transition means that you move it from one storage class to the other. So with this, what it means is that maybe, so when it comes to data, there's a concept of hot, warm, and cold, right? The hot would have a higher temperature than warm, and warm will have a higher temperature than cold. So let's relate temperature to how frequently data is accessed. You get a concept. So hot means that data is accessed frequently, like all the time. It's very hot. Warm means that data is being accessed, all right, frequently, but not as frequent as in the hot tier. And then cold means that data is not accessed at all, or it's not accessed frequently. So that's what that's what means. You refer to them as data tiers. They are used across multiple applications or instances, right? So usually you want to transition your data when they be from hot to, let's say, warm, and then from warm to cold, right? So maybe your data is being accessed frequently, and maybe when, let's say Twitter, realize that, or let me use, let's use Twitter, right? Let's say when a match is happening, everybody's talking about it. So when you tweet about a match, you get a lot of replies and a lot of retweets and all that, right? And likes and all. Like a lot of people are interacting with the data using that data. After maybe 5 hours, there's the latecomers who come and like or say something. And by then, the engagement will be gone, right? Everybody has moved on. The next day, almost nobody will ever come back to it, right? And maybe after 1 month, nobody sees it at all. So realize that that interaction has a certain life cycle. So let's say your data that is stored also behaves like this way, right? It means that after some time, you can move it to infrequent access. And then after some time, you can say it should actually be archived. because maybe you need it only for regulatory purposes. So transition will move it from one class to the other. So there are other things you could do to your objects or even buckets. There's a feature called versioning. So versioning will allow you to keep multiple versions of your object. So maybe you have an application where your users need to upload their profile picture. You can only have one profile picture at a time, right? So if I upload my profile picture today, it becomes the profile picture. If I've enabled versioning, it becomes version 1. Maybe 2 weeks time, I'll take a better picture and then I'll come and update it to version 2. Now, by default, if I've not enabled versioning, it means that my new profile picture should override my previous profile picture. However, if I enable versioning, then it means that I'm going to keep both profile pictures, just that the one I upload in 2 weeks' time becomes the latest version, and that is what is referenced. I could actually go back and reference the old one. You know that. This allows you to keep multiple versions of the same objects, and then you can restore it if you want a previous version, you accidentally deleted a certain version, or you've overwritten another version, right? Now, if you don't want another way or another feature is the version lock, where when you upload an object and you enable version lock, you would not be able to delete or overwrite it for a certain amount of time, or even indefinitely, right? You could also replicate objects to other regions, right? Or other buckets in the same regions. Maybe you want to have a global application with data in S3. So when data is uploaded to one bucket, you want to automatically copy it to another bucket. Your application will help you do that. If you're uploading files greater than 100 MB, you're advised to use the multi-path upload. Multi-path upload basically will break your object into multiple parts and then try to upload all of them or a number of them at the same time. This would ensure that your upload would use the maximum bandwidth available, and then also it's faster. Transfer acceleration. So we spoke about replication, right? Now, if you want to, how do you call it? If you want to upload data to S3, so maybe your bucket is in US East 1, that's Virginia, right? And you are in Accra. We spoke about the global infrastructure last week. It would usually, you select regions closer to you, right? And we also mentioned that AWS has edge locations all over the world. They have about 400 edge locations and only 26 regions. So these edge locations are closer to you. So if you want to upload files quickly to S3, transfer acceleration is a feature you could use. What it is that instead of transferring the files over the internet, you would actually upload the file to S3, and the file goes to an edge location, first of all, and then the file would go over Amazon's private network to your bucket. So it's faster. The latency is also lower because the edge location is closer to you. So what you have to do is get the file to the edge location, and then it's transported internally in Amazon's network. So you'd also you can use transfer acceleration with the replication we spoke about to make copying of files quicker. Glacier, I spoke about archiving data. So Glacier is used to archive data and for long-term backup. When you use Glacier, it means that you're not accessing the files frequently, right? It's just there for compliance purposes, or you need to keep data for a long time. So with that, you're actually not accessing the file. There are three modes Glacier can operate in. And instant retrieval would allow you to access your file within milliseconds. Flexible retrieval will be within minutes. And then deep archive is when you may not even access the file, or you readily need to access the file. And if you need to access files in Glacier, even though the storage becomes cheaper, when you need to access the file, you pay a lot more for it, actually. So you have to keep that in mind. If you need to access the files, maybe sometimes, then you use the infrequent access options and not Glacier. If you think you may not need to access it, or you may access it once in a long time, then you can use the Glacier. Okay, so S3, we looked at assuming a role to access S3 in our first meetup. So maybe we can skip this demo and then look at relational databases. Relational databases, last week we did a demo that used Aurora, even though we didn't explain much about it, so we're not doing a demo for that. So let's look at relational databases. There's a service called Relational Database Service. That's RDS. What's RDS? So it makes it easy to set up and operate a relational database in AWS. It's likely that some of us don't know what relational databases are, but it's also I'm sure we all know what SQL is, or SQL, right? So SQL, relational databases basically use SQL. All relational databases use SQL. And the reason why I say they are relational is that you typically have tables that reference each other, right? Or relate to each other. And their relational databases have a lot of constraints to make sure that your data is consistent. So you'd have things like schema that would define beforehand how your data should look like. So that's like a 1080 degrees overview of relational databases. However, if you want to create relational databases in AWS, use the relational database service. It's cost effective, it's scalable. You can choose any capacity size. The cool thing about it is that most of the work you'd have done managing or administering a database is done for you already by AWS, right? So you don't worry yourself with a lot of this. The backups and all that can even be done for you. So in RDS, you typically have a database instance, which is it's not an EC2 instance, but the same concept. It's a virtual machine. And but purposely for the database, you can't SSH into it, but you can connect to it using your database client. So your RDS would usually have a DB instance, which would be created in a VPC or an availability zone. The database instance is the basic building block of RDS, because you have your database running in the DB instance. So closely associated with the DB instance is the instance class. Remember we spoke about, in compute, we spoke about instance types, and we said they determine how much CPU and memory you have and all that. So the instance class is the same thing. So I said that when you run your database in a production environment, in your own data center, there are a lot of work you have to do. So this table is comparing the work you have to do when you run your own database on-premise, and then when you run your database on EC2. So realize that all of them are similar. So this one, you're running your database on EC2, not RDS. You can actually run your database on EC2. It means you do a lot of the work. And when you run your database on EC2, there's no difference from when you run your data in your own data center. The only difference is that AWS will take care of the server maintenance, maintaining the EC2 service for you, the hardware, the power, the network, and cooling. Outside that, all the things you do on-prem, you do on EC2 also, like installing an operating system, updating it, installing your database software, updating it, doing backups, making sure the database is highly available, scaling it, optimizing your application, all that. You still do it if you should run your database on EC2. The cool thing about using RDS is that when you use RDS, the only thing you have to do is optimize your application. Every other feature you see here is done by AWS. So why do you want to do all this work when somebody can do it for you and you pay them a small amount of money? So that's why most people would use RDS than manage their own database. So RDS supports both commercial databases and open source databases. So the open source databases are MySQL, MariaDB, and PostgreSQL. The commercial databases are your Oracle and the Microsoft SQL Server. So the database types are actually referred to as database engines, right? So each engine also has its own set of supported features and the versions RDS support. So they try to keep up with the latest versions. Because Oracle and Microsoft SQL Server are commercial products, they are licensing related to those, right? So you need licenses to run those. So one concept in RDS is the multi-AZ deployment. We all know what AZ is, availability zone. That's one way you keep your database, but this is how you keep your database highly available and scalable. So with multi-AZ, what happens is that you would have your primary database. That's where your applications would go and read and write records in the database. So that's the primary instance. You'd have your primary instance in one availability zone. Then you have a standby in another availability zone. So what I've described is called a multi-AZ instance deployment. You can actually have 2 standby instances and even multiple writer or writes or primary instances for the multi-AZ cluster deployment. So the cluster will give you more standbys and even a number of primary instances as well. And then the multi-AZ DB instance deployment will just give you one primary and one standby. What a standby is, you can't, whilst the primary is active, you can't read from the standby, right? It's only when it fails. So when it fails, then your database points to the standby. It's whilst your primary is running, it's replicating your data to the secondary. So it's always up to date with the secondary or standby. Yeah. And if it should fail, you already have another database online which has all the changes and updates that have been made to your original database. So it's for fail over. You don't access it whilst your primary is working. So I've gone on to explain the multi-AZ instance deployment and then the cluster deployment. So with the, like I said earlier, with the instance deployment, you only have one primary and then one standby. With the cluster, you have up to 3 instances, and you could have one writer instance, and then you could deploy multiple or 2 standby instances. So RDS would usually give you endpoints or a host address to access your data from. Yeah, so you could have the writer and then a reader. The reader endpoint is only for reading. Writer is for writing database records. Realize last time we used the writer endpoint and we're even able to read from it also. We've spoken about snapshots already, and snapshots, it's the same as you do for your EBS. Your RDS uses EBS volumes actually. So your database is already on a volume, and then they will create a backup for you. The only difference here, or what I should mention here, is that you can enable automatic backups or do your own backups. So automatic backups are done by S3. As you are creating your instance, you would specify a backup window. Also, you would specify a maintenance window. So maintenance window is when AWS can do all the maintenance work, like patching your database, upgrading the software, among other things, right? The backup window is when they can take snapshots for you. Now, your backup window should not overlap with the maintenance window. The maintenance window is usually a weekly time period, right? So you could say maybe Sunday, 12 a.m. to 3 a.m. However, your backup window can be every day. So if you set your maintenance window, which is weekly, to Sunday, 12 a.m. to 3 a.m., means that your backup window cannot be 12 a.m. to 3 a.m. It could be 3 a.m. to maybe 6 a.m., possibly. And the snapshots are incremental, like we spoke about earlier. When you enable automatic backups and AWS is taking an automatic backup, your database may briefly be unavailable as they start the process. Also, you have to set retention period for your snapshots. And you can also configure RDS such that it would copy your snapshots to other regions, your snapshots and transaction logs to other regions. So if you want to recreate your database, you can recreate it from other regions. So snapshots, apart from using them to back up your data, I mean, what's the purpose of backup if you cannot restore? So they are used to restore databases. You could also use it for point in time, which is another type of restore where you go to a particular date and time, the snapshot that was created on that date and time will be used, as well as the transaction logs will be used to restore your database. So that's RDS. Now, Aurora. So AWS has, when it comes to databases, AWS has two favorite children. And the favorite children are Aurora and DynamoDB. We'll be looking at DynamoDB later. Why are they favorite children? Because they are actually developed by AWS. So remember that RDS, I said they support MySQL and Postgres and MariaDB and Microsoft SQL Server and Postgres, right? Aurora supports those, supports MySQL and Postgres. These two are open source database, right? However, Aurora changed how the storage is done for these two databases. So in RDS, Aurora is part of RDS anyway, but it's sometimes a standalone service. So when you create MySQL or Postgres or any RDS with any database engine, you have to create an EBS. You have to create an EBS volume or specify the volume size, right? And the volume is attached to the physical storage. Interesting. Let me just get to my slide. Yeah, so you create a storage for the database also. However, and then your standby would also have different storage, and we also have something called read replicas, right? They also have their own storage. However, in Aurora, you have a shared storage, and all your DB instances would read from the shared storage. So that's the main difference in Aurora. And this allows the database to be optimized such that MySQL can be up to 5 times faster than when it's run by yourself, or when it's run by yourself. And Postgres up to 3 times throughput for Postgres. The shared storage can go up to 128 terabytes. So I didn't say terabytes, it's terabytes. So terabytes is, or when you see MB, it means it's measured using the binary system. So when we say tera, it's actually base 10 or decimal, and that's tera is 10 raised to the power 12, right? Bytes. But tebi is 2 raised to the power 40. When you do the calculation, it's actually similar. The difference is it's just a little. It's not a little like I'm saying, but it's close. Anyway, so Aurora does some of the complex things when it comes to databases, like clustering and replication, right? Later we'll see that you could actually create a global database. So your standard Aurora will be in a region, and then you have shared storage. You could create what you call read replicas, up to 15 of them. So read replicas are used to just read traffic, and usually the concepts, I can explain the concept of read replicas here. You'd in a database, usually you read more than you write. So write is when you set a record or even update a record, right? And then a read is just when you are querying the database. So you do a lot of viewing the data in the database than entering data into the database, right? And so because of that, your database may have several connections, right? And if the connections are, it's possible that the connections cannot be handled by only your primary. So you use read replicas to scale your database such that when people want to read your data, they can just hit the read instance or reader or replica instance and then read the data from that instead of going to the primary, which only handles writes and replicates those records to the replicas. So your replica will still have your latest data because when you write to the primary or the writer, it would replicate those changes to your replicas. So Aurora supports that. RDS also supports that anyway. So this is how your Aurora cluster would look like. You realize that the volume is spread across all the availability zones. You have copies in all the availability zones, and your replicas would read a copy of the volume from their availability zone. When you write, it would also go and write in the copies in the other availability zone. So that's how your Aurora cluster would look like. So there's another service called Aurora Serverless. Actually, there are two versions. There's version 1 and version 2. Version 2 is the latest. So this is based on version 2. And when it comes to Aurora Serverless, you don't even concern yourself with the underlying infrastructure. All you have to do is create your database. You don't know where it is, and then put data in it and read your data. It's as simple as that. So Aurora will handle all the monitoring and adjusting the capacity if it needs to increase the capacities to do all that. Maybe increase the size of your instances and all that, or add more instances. It will handle all that. That's why it's serverless. You don't worry. There are servers involved, but you don't create those servers. You don't manage them. You are just reading your data. It's as simple as it gets, right? So you use Aurora Serverless if you have workloads that are variable. That's the performance required varies. So maybe at one point in time, you have a few writes and then just some specific number of reads. And then there are times that it will burst or there are spikes and all that. Yeah. When you are writing a new application, you're starting from scratch. So you don't care about legacy databases and all that. You can use serverless or serverless, so you don't think about managing any database infrastructure. If you have multi-tenant application, so where maybe every database belongs to a different tenant, you could use Aurora Serverless too. When you are developing or testing a new application, you could also use that. Yes, when you want to avoid overheads with capacity planning, or you don't even want to think about it at all, it's just with Aurora Serverless. So there's also Aurora Data, the global database. What this is that you have your primary database in one region, and then you can create up to 5 replicas in other regions. So your database is copied to up to 5 other regions. So it could be just one other region. Why will you do this? You want a database that is globally accessible, but offers low latency irrespective of the region you are or the part of the world you are. So you let Aurora handle copying the database to closer to your users. And then you would only update the database from one place. And then, yeah, so Aurora will do all the copying or replication for you. And your latency is usually within under a second, irrespective of which region or which part of the world your replica database is at. So that's Aurora database. You can see your primary region to be US West 1, and then there's US 61 as a secondary region. So we could have another replica region in, let's say, Europe, and then maybe another one in Asia, then another one in Africa. So those in Africa will read from the Africa or South Africa region. The Asia, those in Asia will read from the Asian region. Europe will read from Europe, and Americas could read from any of the two clusters in their region. It's 12:11. Let's take a 10-minute break, and then we would come back at 12:10, 12:21, and then we'll look at non-relational database. Our focus will be on DynamoDB. It's the other favorite child. So if you have any questions, you can prepare them. When I come back, then we'll answer a question, and then we'll move on. We'll try and do a demo on DynamoDB if we have time. Yeah, that's important because that's one of the services we've not seen so far. The others, I believe, S3, we've seen it. Are we all back? Guess the break is enough, right? Are we back?
Yeah, we are back.
Okay, good.
Here.
Before moving on, any questions? There's so much material to cover, so yes, I might have gone fast. But do you have any questions so far on object storage and relational database service? Then that file storage also. Have any questions? If you don't ask questions, make me that everything I said you understand. That I'm a good instructor. So ask questions. Ask questions. All right. It's 12:22. We have 38 minutes to go. Let's look at DynamoDB. So we've spoken about Aura and RDS, where you create DB instances and you can either create manual snapshots or automate the snapshots and all that, right? DynamoDB is, it's however, what you call a NoSQL database. So NoSQL means not only SQL, right? Or not only SQL. And all the relational databases we looked at, or when we looked at relational databases, I mentioned some databases, about 6 of them, right? Or 5 of them. And all of them use the particular language, that's SQL, to query the database. So when we did our activity application, we realized that I entered the command to search data into the database, and then there was another command the application was using to read the entries I have made, right? So that language is SQL. However, NoSQL databases, they don't use SQL. That's one feature about them. And they may have their own query language. So almost all of them use a different query language, or you have to query it, use different ways to query from your application. So each one is different. They may be schemaless. So you may not necessarily define a schema at the beginning when you are creating your table to say that maybe this columns should be there, it should be this data type and all that. Some of them you can even define a schema and then insert some data that's or some attributes that's not even in the schema. So they are flexible and they are fast also, right? Yeah. So DynamoDB is one of them. You could use DynamoDB to store your data. So in DynamoDB, you have what you call tables. So you need create tables. The relational database, you have what you call a database, and then you create tables in there. The tables are in the database. However, in DynamoDB, you can just go and create a table. The same concepts here. So you could also allow DynamoDB to back or create backups of your tables, DynamoDB. You could expire items. So maybe create a record in DynamoDB, set a time to live for it, and then when that time gets that time, the record is taken from the database. If you do this, then you'll be saving costs because the items you store, you only store items that are relevant to you, right? And when they are no longer relevant, they are removed, reducing your storage. So I mentioned the table. So a table will be a collection of data, and the table will contain items and then attributes. We look at what items and attributes are very soon. So a table could be a table about maybe people, right? Where you store their name, their contact, their family members, their address, some of our items. So an item, a table can contain 0 or more items, right? And an item would also contain attributes. We look at what attributes are. However, an item is used to identify a unique to identify a unique record or entity, right? So maybe we have a table called people. An item is an entry you'd make into the table. However, every entry should be about one person. So maybe our first item could be about me. So my name would be Mano Kumse, my address would be there. Then the second item or entry could be Edwin, with his name and address. Yes. So I'll not come and add another item, Edwin again, representing the same Edwin. No. It's a different Edwin, maybe Edwin Kumado or something. So we have also what we call attributes, right? And then attributes are the fundamental data elements. You can't break them down. So maybe name is an attribute. How do you break name down again? Can't. Age, date of birth, those sort of things. Those are attributes. So that's what we just looked at, right? We realized that like sometimes I forget to make the screen big. Good. So we have a table called people. Each smaller box is an item, and all the entries you see there are attributes. So you realize that my first item has a person ID, last name, first name, and then phone ID, right? My second item does not have phone, but has address. And then the last one does not have phone, has address, and then has favorite color, blue. You can't do this in a relational databases like MySQL and Postgres, right? They all have to follow a certain schema. That's what it's called. Even if there's no value, you set it to now, and then there'll be no value for a particular column. However, in non-relational databases or NoSQL databases, you could actually make it schemaless, like every entry would have a different schema. So that's how an item will look like in AWS. So there's a concept of primary keys. Remember I said there's no schema in no relational databases, right? And that's not 100% the in AWS, in DynamoDB, you, even though it's schemaless, you have to specify some schema when you are creating the database. And that schema, you only need to specify your primary key, right? There are two types of primary keys in AWS. Sorry, I keep saying AWS. Forgive me. There are two types of primary keys in DynamoDB. And one is a simple primary key, the other is the composite primary key. So the simple primary key contains what we call a partition key. A partition key is a value that is used as an input to a hash function, right? And that hash function will give you an output, which will tell you where the data should be stored. So in DynamoDB, data is stored in partition. Remember I said that those NoSQL databases are fast. So use partition to store data at different locations, right? And then when you are looking for the data, you know the location it is at. So you go and pick it from that location. So that makes it fast. The locations are basically called partitions, right? So the hash function will use your partition to determine where the data should be stored. Now, let's go back. Realize that person ID in all three items has been bolded, right? It's in bold. So that's our partition. And you realize they are all different. So your partition key or primary key must always be different. There are situations where your partition key may not be different, right? So for instance, if we have, let's say, what we call assets of maybe people, then one person can have like 5 assets. However, their partition key is their ID. So it means that everywhere, if I have 5 assets, everywhere my assets or an entry with my assets will have the partition key of my ID, which will be 111. And I said that primary key should always be different. Right? So you could use what you call a sort also. And the sort key is another attribute which you use together with your primary key to make sure they are different, right? So maybe my sort key, it could actually be anything, but you make sure that your partition key and sort key combinations will always be primary keys. So when you combine them, it comes with it. And then now this is passed to the hash function where your data should be stored. So you don't use a partition key or a sort a partition key with a sort key to make your primary key. So the primary key becomes the only attribute in your table you need to define beforehand. Every other attribute can be defined with data or added data. There's also a concept of secondary indexes. We still go back to the feature of NoSQL databases that I said makes them fast, right? So one of the ways to make sure that you can read data quickly is by using what is called a secondary index. A secondary index will allow you to query data using an alternate key. So your table will come with a primary key, which would be with a sort or a partition key, right? However, you get a secondary key, now you can specify a different key. So with local secondary index, you'll be able to use the same partition key, but you specify a different sort. With the global secondary, now you can specify a different partition key and a different sort. So that's the difference. I think you can create up to 5 local secondary indexes and then up to 20 global secondary indexes. What they do is they allow you to read data in a different way, right? So I mentioned that your primary key determines where your data is stored. So when you want to query the data, your table now, and you don't want to use the initially defined primary key, you can create a secondary index, which would use a different sort key, but the same partition key to create a view of your table. And then you can read quickly from that view. Mind when you are making queries, you typically use your primary keys to query your data. The difference between the two is that global allows you to change both the partition and sort keys. local only allows you to change the sort. So you have a table called music, and now we can create a secondary index called genre album title. So this secondary index is actually created from your table, and you realize that it has all the attributes in your table. However, this time you have 4 attributes to be available, right? And so this would be a global secondary index, because your partition and sort keys, the secondary index, are different from what is in the original table. The original table, your partition key is artist, your sort key is song title. In your secondary index, your partition key is genre, and your sort key is album title. So this becomes a global secondary index. So you'd use this when you want to read or make queries based on your genre and album title. But the default queries would be against the original table, which would use artist and song title. So when it comes to reading and writing, DynamoDB uses what we call capacity modes, right? So you have read capacity units and write capacity units. However, there are different ways to consume those. So you have what you call on-demand and then provision. On-demand, you don't necessarily say how many reads you want to do at a time or how many writes you want to do at a time. It's provisioned that you tell Dynamo how many reads you want to do at a time concurrently and how many writes you want to do concurrently. So provision will allow you to specify that. On demand will just allow you to make a write when you want to. And that determines your cost also, right? So if you use on demand and original every second that you pay more, and you only restricted what you specify. You can use auto scaling to scale your provision capacity. There's a concept of read consistency, right? So, mind you, all the AWS services are distributed applications, right? So, applications that they are not on one server, right? They have different components at different places. So, usually, I mentioned that S3, when you write data, you put data, it's replicated to about 3 different, or the object is copied to like 3 different availability zones, right? So what happens when I write data now in switching to availability zone A, it's been with maybe after 1 second, it's switching to availability zone B, and then maybe after 100 microseconds, it's switching to availability zone C, right? When I'm reading the data may not be the same or may not have been written to all the agents, right? Yeah, the same concept applies to Dynamo. So there's the default consistency, which is the eventual consistency, which means that eventually all the places the data needs to be written to will be updated as such. However, it would be updated, let's say, 1 at a time. And so when you want to read, you may not, depending on where the data is picked from, you may not get the current version of the data or the updated version. You may get an old form of the data, or even say the data is not available. Right? So that's eventual consistency. However, strong consistency or strongly consistent reads would mean that you get the most up-to-date data. So that may come with a higher latency. And then also you need more capacity units to do strongly consistent reads. Table classes, we looked at table classes or storage classes in EFS and then S3. The same concepts apply here, right? But over here, we only have the standard and then the infrequent access. So I've explained the standard and infrequent access over and over and over and over and over and over again. The same explanation applies here, although it's a different product. So there's a concept of transactions, right? Where maybe you have a number of operations to do on a database, and you want all of them to succeed before you say that that operation was successful. Or if one fails, then you roll back the entire operation. So that's a transaction. You typically do this in a relational database. Yes, you usually do this in a relational database, but DynamoDB also supports this is a feature that allows you to have this feature which was traditionally available in relational databases. Yeah. So you need more capacity units to also do transaction-related operations, whether it's read or write. Yeah. Then there's DynamoDB Accelerator. You realize I'm rushing here because I want to at least show you the DynamoDB interface. So before we close. So DAX is basically a caching service. You can use DAX with DynamoDB. When you use DAX, you don't do much changes to your application. Right? Your data is cached, and then you can easily access it or access it quickly. So caches usually use memory. Reading from memory is quicker than reading from disk. So cache would easily keep your data. So that's what this cache is. That is for DynamoDB. Reduce your latency, and you can use this for your workloads that would spike. And so when you use DAX, you're not necessarily using your capacity units on the database because it's read. DAX will read it and then put it in the cache, and then you would access it from the cache. So Joey, you have a question?
Sorry, there's not a question, but I'm getting a feedback like a scratchy sound. I don't know whether I'm the only one.
Okay, let me stop
from your.
Am I still audible?
Yes, it's better now.
Okay, all right. All right. So DynamoDB streams. Sometimes you want to act on data that is added to is written to DynamoDB table, right? Or when you update data or an item, or when you delete data from the table, you want to act on it. So maybe you have an application where when somebody signs up, you want to send an email to the person. You could use streams, DynamoDB streams, such that when an entry is made, a stream record is created, and then maybe a Lambda function can pick it up and read the email and then send maybe an email template to the person. So yeah, so that you call that a trigger, right, for Lambda. Maybe you also want to copy the data to another region or to another table or to Kinesis. That's one of the AWS services. We may look at it in the last session. So streams will allow you to act on data that is written to your table or is updated or deleted. So that's what streams are used for. DynamoDB also has global tables. Remember we spoke about global, what do you call it? Aurora global database. So this is similar. However, with the DynamoDB global table, you can, they're multi-active database. So you can, each database is in a region, right? So you can write from region A and then it will replicate in region B or the other regions. You could also do the vice versa and write in region B and it will replicate in A and then the other regions. Yeah, there's nothing. You could also have different, you could configure different capacity units for the different tables in different regions, right? Because maybe in a specific region, you expect more traffic than other regions. Yeah, and with the global table, the tables will have the same name in different regions, right? So, and the same items also. So we do a demo. We have 13 minutes, right? So maybe let me quickly run through the other NoSQL databases. This is not a database specialty bootcamp, but they may get asked when you check the exam guide, all the services are in there. So DocumentDB, if you know MongoDB, DocumentDB is a database offering from AWS that works with MongoDB. So if you have an application that writes to a MongoDB database, you can use DocumentDB. If you have a MongoDB database, you can migrate it to DocumentDB. You run this in a VPC. Your storage scales to up to 64 terabytes. You could have up to 15 replicas. This also uses the same underlying storage like we saw in Aurora. You could have reader endpoints, and then you encrypt the data with KMS. So documents, MongoDB is what we call a document database. You can just put a data structure like a JSON data into the database and query it as such. The same for MongoDB, documents. Neptune is a graph database, and graph databases usually have or store relationship between different entities, right? And you can query the graph database with popular graph query languages like OpenCipher and Sparkle and Gremlin. So you realize that one database, there are 3 different languages you can use to query it. Unlike the SQL databases that only use SQL as a query language, right? So graph databases are used for fraud detection, recommendation engines, drug discovery, and network security. You could have read replicas, do point-in-time recovery, backup to S3, and then use multi-AZs for replication. Elastic cache. So Elastic cache, you have 2 different caching solutions, Memcached and then Redis. So if you want a simple setup, you use Memcached. If you want complicated and want to do things like streams and pub, sub, you use Redis. The next slide is on Redis. The other thing you want to use Redis for, or you choose Redis when you want to be compliant. So Redis is HIPAA compliant, PCI DSS, and then FedRAMP. So the security in Redis is higher than in Memcached. Redis would also allow you to tear your data between memory and storage. So caches are, I mentioned earlier that caches store data in memory, right? So, but as we know, every resource is limited by capacity. So if your memory is, or if you have more data in your cache than memory, you could cache the code data, or you could move the code data to storage when you're using Redis. So that's one thing Redis can do, and Memcache you cannot do. So like I said earlier, if you want advanced features for Elastic Cache, use Redis. If you want something simple, you go with Memcache. OpenSearch. OpenSearch is just the successor to Elasticsearch. So Elastic, the company that maintains the Elasticsearch service, it used to be an open source software, but after version 7.1, they changed the license, meaning that other people like AWS cannot use it and sell it or create services around it and sell to their customers. So Amazon also created a fork from the last open source version and called it OpenSearch, and they develop it from there, or they add new features from that last version. So OpenSearch, like Elasticsearch, can be used to index documents, and by index documents simply means you put data in there and then you can analyze it. So you can analyze logs, monitor applications in real time, and then even analyze click stream. So which areas of your websites people are clicking and how they're interacting with your websites and all that. So that's OpenSearch. It's Elasticsearch from AWS. Then there's a Quantum Ledger database. So if you want an audit trail for all your changes, use Quantum Ledger database. Typically, you write applications to do this. A whole lot of maintenance and applications and other. But QLDB will keep an immutable transaction log. So immutable means that it can be changed, and that's known as a journal. From what I've said, people may start thinking it's blockchain, but Amazon actually has a blockchain service, and this is not blockchain, it's QLDB. So there's also TimeStream. It's used for data from IoT devices and servers and other applications, right? It's used to store TimeStream data, so data that has time. So like maybe an IoT device reporting temperature and humidity every second. Yeah, so such data. And it's very fast for such applications. You could also use it to measure or monitor your infrastructure actually. So that's what TimeStream is for. The name suggests it works with time series data. All right. It's 12:54. So what do we do? Let me pause here for questions first. If I say I'll do this demo, to take time. But let's do this. Maybe I'll just show you the interface again. If you have a question, you can raise up your hand or mute your mic and then ask. No questions. Hey, all these places things I said, people have no questions. So like to see where we come here, the first thing is to create a table. We can call this what? Music, artist, then a sort key, maybe song title. So in DynamoDB, you can say data could be of type string. You have what you call a scalar. So a scalar is a string, number, a boolean. Your sort and partition key would have to be any of this. But if you create any other attribute, it could be a set or a nested data. So you could have maybe addresses, and then in there you have address 1, address 2 with different data and all that. So that could be a map or a list. So table settings, let's select customize and see. You have standard, you have standard IA. Now you see the capacity we spoke about. So there's some mass to the capacity units. Maybe I wanted to do that in the demo. Since I'll not be able to do it, I can spend the rest of the time explaining the math. Okay, so when it comes to capacity units, right? If you want to write every 1K of data is one capacity unit or one write capacity unit. Every 1K, that's 1 kilobyte, right? So let's put this off. We don't have a hand up. Okay. So this is, so let's start with, what happened to my screen? Okay. Let me go back to, all right. So I'll say that every 1 kilobyte of writes would use 1 capacity unit. If we want to do a transaction, then that's 2 times. So 1K transaction would require 2 capacity units. So, okay, yeah, this is what I was looking for. Good. So realize that when I set it to 4 KB, I have 4 capacity units, right? Okay. Now, every eventually consistent read up to 4K would require 0.5 capacity units, right? Okay, so that's eventually consistent. Okay. If you want strong consistency, then that is 1 capacity unit. So maybe if we are just noting this down. If you want a transaction, then that becomes 2. Yeah, you multiply by 2. So if I have more than 4 KB, so a DynamoDB item could be up to 400 KB. So it means that if I have 400 KB, that should take up all the read, 100 read capacity units for strongly consistent. Okay. Then eventually consistent, remember I said 0.5, so that makes it 50. Now, you see the estimated cost here. This is capacity you are giving to your data. So, sorry, your table. So it means that you could do up to I'm coming. So if with this, if I want to do right now I'm reading one read per second. Okay. So if I want to do maybe 20 consecutive reads per second, then my cost keeps going up. So the number of items you're able to read per second determines your cost. How you read it also determines how much you pay, or how you write it, whether standard or as a transaction. It also determines your cost. So you realize this can get expensive. That's where we are right now. If the items putting in a 400 KB. So let's say maybe I doing just 1 KB. All right. So very small data. You realize you are spending less than $2 a month. But if the data is a lot, then it's going up because we spoke about capacity units. Remember that every 4 KB strong consistent read requires 1 capacity unit. Every 4 or up to 4 KB reads or eventual consistent reads require just 0.5. When it comes to writes, every 1 KB requires 1 write capacity unit. If you want to do a transactional write, then that is transactional write is 2 capacity units per KB. So I think that's all you need to know. Our time is up. I'll pause here for questions. If there are none, we can close, and then I'll see you on Saturday morning to wrap up this bootcamp. So, any questions? Any hands up? It's 1 o'clock. Nana Eko Isando. Over to you.
Mine is a general one, not
Okay.
really pertaining to what we are. How much of what we are learning will apply to the various associates? I'm studying for the Solutions Architect Associate.
Then
but
everything
will
you
it
learned here
transfer?
applies.
Okay.
Okay, so Dynamo
let's give
DB.
knowledge. Okay.
Dynamo DB, you may need it in developer, but not sysops.
Okay.
And then RDS, not necessarily in developer, but you may need to do some monitoring and snapshotting in sysops. EBS, you need it everywhere, I guess. EFS, mostly associates and solutions architects. Yeah. So, yeah, I think most of this applies to associates and sysops.
Okay. That's good to know. Thank you very much.
All right, you're welcome. Okay, looks like there's none, and we have people giving thumbs up.
I have a question.
Okay, go ahead.
Okay, this one is general. I just wanted to know when this tutorial will be uploaded, because we have to go through and then meet you on Saturday as well, so that if we have any concerns.
Yeah.
Yeah.
Okay. We'll try as much as possible to get to you before Saturday. I think we've not uploaded the networking, right? Or it's,
yes, it's still not uploaded.
Yeah, we had to do a lot of editing to the networking one. So yes, that's not available, but we hope to post both very soon before our Saturday session. Yeah.
Okay. Because right now it looks like a lot of them. They have to be.
Okay, I get you. So Saturday I'll try and touch on a lot of general concepts, right? Some of the architecting concepts, and then we will solve questions on Saturday. Maybe we should start with solving questions so that we don't leave that one out, right? So Saturday we will solve questions. The week 1 and week 2 videos are available on YouTube, AWS Accra channel. So those of you asking, let me quickly get you the link, and then we close. So if you have any other questions, you can ask now, or after I share the link, you go home and go enjoy the rest of the holiday. So you can see here, Bootcamp week 1 and week 2. So let me share the channel with you in the chat, then we can close chat. Make sure you copy it before we end the meeting. Copy right now because we end the meeting right now. Okay, so since there are no other questions, we can call it a day. Thank you all for attending, and I'll see you on Saturday. Saturday, I also share preparation materials, right? And where to find questions for free and all that. I have to pay something to somebody for good material though, so we shouldn't really be concerned about the free materials. Okay, all right. So we have closed. Thank you, everyone. Have a good day.
Thank you, sir. Thank you.
Bye-bye.